Namaste. I'm Chris Kumar. On behalf of NPABSAN Kaski, I'm going to take the class 8 on the relation matter. So let's make the matter easier than you expect. Matter, all the things around us are called matter. They are found in the form of elements, compound, or any other types of nature. First of all, let's study about the planet. The simplest pure substances that can neither be split nor can it be made from two or more substances by any method is called planet. For example, hydrogen, sodium, magnesium, silicon, iron, copper, etc. are the elements. On the basis of physical and chemical properties, elements are divided in three groups: metals, non-metals, and metalloids. For usual, I have made them in tabular forms. Metals, the substances which are shiny and good conductor of heat and electricity are called metals. They are malleable and ductile. Malleable means when they are heated, they form a thin film. And ductile means when you stretch it, it makes a wire. For example, copper, iron, silver, gold, mercury, etc. are metals. Mercury is found in liquid state. Non-metals, they are dull. They are bad conductor of heat and electricity, except carbon. Carbon is a good conductor. Example, carbon, oxygen, nitrogen, etc. are the non-metals. Metalloids, the substances which have both behaviors, properties of metals and non-metals are metalloids. Some of their properties have been written here. Some are shiny, whereas some are dull. They become a good conductor at hard condition 1. So they are called semiconductor, or they conduct heat of electricity. Example, silicon, germanium, arsenic, antimony, etc. Structure of the atoms. At the center, there is a nucleus. It contains proton and neutron. Nucleus is surrounded by the circle, the pathway of the electrons. That is called cell, orbit, or energy level. Here it is the structure of beryllium. Beryllium has 4 protons, 5 neutrons, and 4 electrons in their shell. So this is a nucleus, and this is first cell, K cell, and this is a L cell. The second topic is compound. A pure substance which are formed of 2 or more elements in fixed proportion or ratio is called compound. For example, water, carbon dioxide, common salt, etc. are compounds. Water is a compound because it is formed of hydrogen and oxygen in the ratio of 3:1. That means 2% of hydrogen and 1% of oxygen combines together to form a water. That's why water is a compound. Another topic is molecules. The smallest particles of either element or compound which can exist freely, they are called molecules. The molecules of an oxygen is O2, which is made of 2 atoms of oxygen. So O2 and just O, that is the difference. O is an atom and O2 is a molecules. O2 is made of 3 atoms of oxygen. Again, we talk about the atoms. The smallest particles of an element that takes part in the chemical reaction is called atom. The structure of atoms I have shown already about you where in previous drawing. Now, atom is made of three subatomic particles. They are electron, proton, and neutrons. These are very tiny particles that make the electrons. But the atom cannot be split into simpler forms. The subatomic particles, once again, electrons, protons, and neutrons. Electrons, the symbol is E with negative charge. It has a negative charge. It has a mass equal to 1 upon 1837 parts of the hydrogen. That means it is very little mass which is negligible, and we do not include the mass of electron in the case of mass of atom. It is found in cell. So electrons are found in the orbit in the cell around the nucleus. That is called cell energy level orbit. And again, the cells are subdivided into the orbitals. They are called SPDR. We'll study about it in class 9. Proton, it has negative charge. It has mass equal to 1 hydrogen. So hydrogen is taken as a standard atomic mass. It is found in the nucleus. Protons, they are located in the nucleus. The third particle is a neutron. It is represented by small n with power 0. It is neutral, that means it doesn't bear any charge, neither positive nor negatives. It has mass equal to 1 hydrogen. So the mass of 1 neutron is equal to the mass of 1 hydrogen, because hydrogen has 1 electron and 1 proton, no neutrons. It is also found in the nucleus. Next topic is atomic number. The number of protons or electrons of the atoms of an element is called atomic number. It is represented by Z. So atomic number means the total number of protons present in the nucleus are the total number of electrons present in the cells. That is called atomic number, and it is represented by Z. Formula: Z is equal to P or Z is equal to E. Atomic number equals to number of protons or the number of electrons. Atomic mass. The sum of the number of protons and neutrons present in the nucleus of an atom is called atomic mass of the element. It is also called atomic weight. It is denoted by capital A. The mass of electron is negligible because the mass of electron is 1 upon 1837 parts of the hydrogen. That's why the mass of electron is not included. Therefore, we have a formula of atomic mass. A is equal to P plus N. Number of protons, P means, and N means number of neutrons. A equals P plus N. Molecular weight. The sum of the atomic weights of all the atoms of the elements present in the molecule is called molecular weight. Molecular weight of water is 80. Molecular weight of water is 2 into 1 plus 16. That means 2 hydrogen, and 1 hydrogen has atomic mass 1, but 1 oxygen atom has 8 protons plus 8 neutrons. That's why 16, and altogether the sum will become 18. electronic configuration of an atom. The systematic distribution of electrons in the cell or energy level or orbit of an atom is called electronic configuration. So here the atomic structure of sodium is given to you. We draw a circle at the center as a nucleus which contains 12 neutrons and 11 protons. The first cell, K cell, contains just 2 electrons. K cell can hold 2 electrons. The second cell, L cell, or second cell, that can hold 8 electrons, 2, 4, 6, and 8. The last cell, it is also known as valence cell. The valence cells contains just 1 electron and it is called valence electrons. It takes part in chemical reaction. It determines the valency of the element as well. Next topics are important, twice and square rule, which is also known as Bohr-Maury scheme. Twice and square rule means the arrangement of maximum number of electrons in different cells of an atom is known as twice and square rule, whereas N means number of the shell. So K cell can hold 2 electrons, that means K is a first cell. According to this formula, 2 into 1 square, 1 square means 1 and 1 into 2 electrons. Similarly, L, M, and shell can hold 18 to the electrons by twice and square rules. For example, this is your second cell, and it is L cell. Here, first, second, N means 2, so N square is equal to 2 square. So 2 square means 4. 4 into 2, 8. So L cell can hold 8 electrons. Similarly, N cell can hold 18 electrons and N cell can hold 32 electrons. The outermost cells of the atom is called valence shells and the electron is called valence electrons. It takes part in chemical reaction and it also determines the valency of the electrons. The next topic is radicals. An atom or group of atoms having a positive or negative charge and act as a single unit in a chemical reaction or during chemical reaction is called radical. Once again, radical. An atom or group of atoms having a positive or negative charge and act as a single unit in chemical reaction is called radical. There are 2 types, electropositive radicals. They are also known as basic radicals as well as metallic radicals. And electronegative radicals, they are called acidic or non-metallic radicals. These radicals, on the basis of constructions, their formation, they are grouped into 2 types as well, simple radicals and compound radicals. Carbon has 4 positive charges, nitrogen has 3 negative charges, oxygen has 2 negative charges. But all these elements are made of only 1 atom, so they are called simple radicals. They are simple radicals because they contain only 1 atoms. Similar, but oxygen 2 negative charge, nitrate NO3 1 negative charge, carbonate 2 negative charge are called compound radical because they have a group of some atoms. Here oxygen has 2 atoms, so it is a compound radicals. Nitrogen is 1 nitrogen atoms and 3 atoms of oxygen, so it is also compound radicals. And carbonate is made of 1 carbon atoms and 3 oxygen atoms. That's why these are called compound radicals. Next heading is a valence sheet. The combining capacity of an atom with other atoms during chemical reaction is called its valency. Hydrogen is a standard element and its valency is 1. So we compare the valency of other elements with the help of the hydrogen. The valency of chlorine in hydrochloric acid, HCl, hydrochloric acid, hydrogen chloride is 1 because one hydrogen combines with one chlorine atom, so chlorine also has 1 valency. The valency of carbon in methane is 4 because 1 atom of carbon combines with 4 atoms of hydrogen. In this way, we can find out the valency of other elements in the compound as well. Now, next topic is molecular formula. The symbolic representation of all the atoms present in the element or compound is called molecular formula. The molecular formula of ammonia is NH3. The symbol should be written clearly in capital N, capital S. They are the symbol of nitrogen and hydrogen. And ammonia is made of 1 part of nitrogen and 3 parts of hydrogen. So the molecular formula of nitrogen is NH3. So from the molecular formula, we get this information. It helps to represent one unit molecule of the substance. It gives the total number of atoms of all the elements in one molecule. It shows the combining capacity of the elements. It helps to find out the molecular weights of the substance as well. So how to write the molecular formula? These are the steps of writing molecular formula in easy way. Just have 3 steps. First of all, we should write the names of the element. The names of the compounds should be written like calcium nitrate. Second step, their symbols should be written. The basic symbols should be written in first, and then acidic radicals should be right. And third, their valency should be written. The valency of the symbol of calcium is 2, the symbol of nitrate is NO3, and calcium valency 2, and nitrate valency 1. Now, exchange their valency, and both this time we should cross their valency, and calcium carries 1, Ca, but nitrate carries this 2, so NO3, 2. Here, 2 belongs to nitrogen as well as for oxygen. That's why we need to bracket here. So, during the calculation, if necessary, we should do LCM of the valencies as well as we should use brackets while writing the molecular formula. Code equation. The process of forming new substance is called chemical reaction. If it is represented by the names of reactants and products, then it is called code equation. So the chemical reaction which is represented by the name of the compound present in the chemical reactions and the products also written in the form of their names, that is called code equation. The chemical substance which takes part in the chemical reaction are called reactant. The new substance which is formed, the new substance is called what? Product. So carbon combines with oxygen, carbon reacts with oxygen. So these are the reactants. They take part in chemical reaction. After the chemical reaction, we get new substance, carbon dioxide. This carbon dioxide neither have the properties of carbon nor have the properties of the oxygen. So it is a new substance and it is a product. Chemical equation. The next topic is chemical equation. The symbolic representation of chemicals reaction is called chemical equation. The chemical equation in which all the atoms of reactants are equal to all the atoms of the product, then it is called valence equation. So if it is not balanced, then it is called skeleton equation. But if all the atoms of right hand side and left hand side, that means reactant and product are equal, then it is called balance equation. A balance equation. For example, hydrogen reacts with chlorine and gives you hydrochloric acid, or we can write hydrogen chloride. The symbol of hydrogen is H2 and the symbol of chlorine is Cl2. These two reactants reacts and gives you hydrogen chloride, HCl. Here, two hydrogen combines with two hydrogen of chlorine but gives HCl, one HCl. That is not balanced, so it is called skeleton equation. But when we write a coefficient 2 here, now the total number of hydrogen is 2 here and total number of atoms of chlorine here also 2 atoms, but here 2 atoms of hydrogen and 2 atoms of chlorine. This coefficient 2 belongs to both hydrogen and chlorine. Now the number of atoms in reactant and product are equal, so it is called balanced chemical equation. Periodic table. So to make chemistry easier, to make study of elements, because we have 118 elements are there. So make it easier, we have groups classified all the elements in tabular forms to make it easy. The systematic arrangement of all the elements on the basis of their properties in the tabular form is called periodic table. So Mendeleev also has given us the Mendeleev periodic table, and nowadays we use the modern periodic table. Mendeleev periodic law. It states that the physical and chemical properties of the elements are periodic functions of their atomic mass. It is formulated by Dmitry Mendeleev in 1969. So the chemical and physical properties of elements are periodic function, means these properties are repeated after some interval. After some period, the same properties, some characteristics are repeated according to their atomic mass. The defect of Mendeleev periodic tables, the position of hydrogen is not properly arranged. Some chemically dissimilar elements are also placed in some same groups. Some higher atomic mass elements are also placed before the elements of low atomic mass. Metals and non-metals are not placed separately. Modern periodic law. It states that the physical and chemical properties of the elements are periodic function of their atomic number. In Mendeleev law, according to the mass, but here according to their numbers. So this is the periodic tables, and in the periodic tables there are 7 periods and 8 groups, but there are 8 chromons. These 8 chromons are divided into 8 groups. Periods. The horizontal rows of the periodic tables are called periods. There are 7 periods. The first, second, and third periods are short periods. The 4th, 5th, 6th, and 7th periods are called long periods. The number of cells determines the periods. Groups. The vertical columns of the periodic table is called groups. There are 18 columns, but 8 groups. The number of valence electrons determine the groups. The groups from 1A, the groups from 1 to group 7 have 2 groups, A and B, and group 8 has 4 groups. Group 3 chromons of group AB and 1 chromon of group 8, 0 groups. Now, some of the groups in shorts. Group 1A elements are called alkali metals. They are helium, lithium, sodium, potassium, etc. belongs to these groups. They are 1 valence electrons. They are very reactive metals. They are low melting points. They react with water and gives alkali and hydrogen. That's why they are called alkali metals. Group 2A elements, or they are called alkaline or metals. Beryllium, magnesium, calcium, etc. are called group 2A elements. They are 2 valence electrons. They are reactive metals. They are found on the orbitals. They have 2 valency, and since they are found on the orbitals, they are called alkaline orbital because they form alkali in the reaction with the water. Group 7A or halogens, fluorine, chlorine, bromine, iodine, etc. belongs to these groups. They have 7 valence electrons, but they are valence each one. They are very reactive non-metals. They react with the water to form the acids. So, halogen reacts with the acids and gives as halogen reacts with the water and gives acids. That's why they are called halogen groups. Group 8A elements, or they are also called noble elements, inert gases, helium, neon, argon, tritium, etc. All these elements have all these elements have 8 valence electrons except helium. Helium has 2 electrons, and rest of the elements have 8 valence electrons, and they have 0 valency. They are non-reactive elements, so they are called noble elements, inert gases. They are chemically reactive. Now, the course of lesson is completed, then all my students can do the exercise of their own textbook. Thank you very much.